amount of fresh drinking water on this planet seemingly appears endless. Good drinking water is becoming scarce, while the world population is still growing strong. As a result of growing industrialization and the heavy clustering of people, more and more wastewater is produced. And all too often, it is released untreated into the environment. Most substances in wastewater can be broken down by natural processes. However, these days the environment is totally overcharged. Thus, too much fertilizer and/or poisonous substances reach our natural waterways, whereby many plant and animal species are eradicated and only a few others can prevail. Pathogenic agents released into natural waterways often reach humans by food or by drinking water. In light cases, they can cause just diarrhea, in difficult ones, illnesses like typhus, hepatitis or cholera. All these reasons clearly show that wastewater should be cleaned, and industrial wastewater should undergo additional pretreatment. However, conventional sewage plants are expensive to construct and to maintain. They require much electric energy and raw materials, and they produce tons of sludge, which must be treated or at least redispersed. Here we present a system which has many advantages over conventional sewage plants. Named after its inventor, Professor Toha, it offers a good cleaning capacity. It is considerably cheaper and it respects nature in a most stringent way, the Tohá system. This is Mr. Icasa, a retired engineer who lives with his family near Santiago. This small tank is fed by the two houses which lie well hidden behind some trees. Here it is roughly filtered. When the inflow has reached a certain level, it is pumped through subterranean pipes into a large storage tank. From there, it is dispersed over the biofilters. In the biofilters, the wastewater is widely cleaned, but still contains bacteria. Therefore, the cleaned water may pass an optional ultraviolet chamber. This is a storage tank of the cleaned water, which is used for irrigation of an extensive garden. And I'm really satisfied we didn't encounter any unexpected problem. We had no inconveniences, no illnesses, things which did not function, no miscalculations. This is to say that everything worked like anticipated. This is the biofilter of Professor Espos, and here we report his testimony. And up to now it has worked flawlessly. Problems encountered with conventional systems like bad odors or clogging up have not occurred. It is an excellent system and very dynamic. The water enters dirty and comes out clean.
Funciona acá el agua sucia y sale limpia.
And so desert land can flourish just by cleaning the wastewater and reusing it for irrigation. This is the research station of Melipilla, built for the wastewater of 1,000 inhabitants. We take samples from the inflow and the outflow and compare the long-term mean values. The biological oxygen demand determines the amount of organic matter present in the water. In the untreated water, it reached about 250 milligrams per liter. Furthermore, we measure the amount of total suspended solids, fine particles floating in the water. A part of them evaporates when heated, the so-called volatile suspended solids. Finally, we measure total nitrogen and phosphorus. High concentrations of them lead to algae blooms and oxygen depletion. All these parameters for measuring water pollution are reduced dramatically by the Tohá system, between 62 and 91%. And so, after passage through the biofilter, the water is clear and ready to undergo optional treatment with ultraviolet rays. Practically all microorganisms get killed by this treatment, and the cleaned water can be reused for other purposes. In his laboratory, Professor Tohá has set up a biofilter to conduct experimental research. He explains. What you see here is a laboratory model of the biofilter to clean wastewaters of domestic or industrial origin. This biofilter has the following structure. In the first step, there is a layer of organic material with living creatures, micro and macroorganisms, and when the wastewater passes through that layer, these organisms pick up, absorb and digest the organic matter, separating wastewater from its main contaminant. In the second step, there is a layer of sawdust supporting the layer above, and this provides additional filtering. In the third step, there is a gravel layer supporting yet other layers, and in the fourth step, larger stones enable an aerated system and the continuation of the filtration process through the biofilter, which always remains permeable. The water runs through the filter just by gravity. It emerges below, clean, without organic matter, and the microorganisms which are still present are eliminated afterwards by a secondary treatment. Here you see a closed ultraviolet chamber. Professor Tohá explains its function. In the second part of the wastewater treatment, we benefit from the capacity of an UV lamp to eliminate the microorganisms remaining in the cleaned water emerging from the biofilter. The water flows in a thin layer in the lower part of this UV chamber, and the water is exposed to the sterilizing effect of ultraviolet radiation. 1999, there were about 24 small Tohá systems installed in Chile. To study the ecology of southern pristine woods in Chile, a whole research station has been transported there by helicopter. In order not to spoil the environment, a Tohá system was installed there too. Larger Tohá systems have been constructed so far near Melipilla for 1,000 inhabitants and in Peumo for 600 inhabitants. Tohá systems for industrial wastewater treatment have recently been built by Chilean, a milk industry, and by agrozzi, a cereals industry which is not shown here. Toha systems are based on the 3 E's. The first E for ecology, because no chemicals are used, no sludge is produced, and very little energy is needed. The second E is for efficiency, because a high degree of purification is attained, and very little space is needed. The wastewater of 5 to 10 persons can be treated by just 1 square meter of biofilter. Finally, the third E is for economy, because the costs for construction and maintenance are low. For a station for 5 persons, construction costs about $500 per person. For 300 persons, $60, and for 12,000 persons, $33 per person. The current trend to release wastewater untreated into the environment can be reversed. The increasing use of ecological, inexpensive and efficient technologies like the Toha system will help to eventually restore our watery treasures of nature.